Welcome viewers, in this video we'll see the Faraday's law followed by the problem. First we'll see the Faraday's law. So based on the statement that total electromotive force EMF induced in a circuit is equal to the rate of decrease of the total magnetic flux linking in the circuit. V equal to minus d pi by dt. This negative sign is indicated decreasing. So due to rate of change of flux, EMF is produced in the coil. If n number of turns available, in the circuit, then the total flux will be n into pi. So V equal to minus n d pi by dt. If n number of turns available, then we can write V equal to minus n d pi by dt. By definition, the EMF in a circuit is a line integral of electric field around a closed path. So the EMF based on in terms of electric field is given as V equal to integral E dot dl. So another form. The previous one based on Faraday's law, this is general form. V equal to integral E dot dl. According to Gauss law, the total flux passing through the surface is equal to the surface integral of magnetic flux density over the surface. So the Gauss law is given pi equal to double integral B dot ds. Right, now we got the expression for pi. Now we will substitute this pi in the equation, EMF equation, that is V equal to minus d pi by dt. In that you can substitute the value pi. So V equal to minus d by dt of double integral B dot ds. Right? This pi is now replaced with the Gauss law expression given by Gauss law. Magnetic flux density in terms of magnetic flux density. V equal to minus d by dt double integral B dot ds. So V equal to, that can be written as V equal to minus integral dB by dt into ds, dou B by dou t, partial differentiation. But V also expressed as E dot dl. Now we can replace this V as E dot dl, so that integral E dot dl equal to minus double integral dou B by dou t into ds. Right? Now we got the expression for this electric field intensity in the single integral to double integral. So by Stokes theorem, this E dot dl equal to double integral del cross E into ds. Right? So the E dot dl from the Stokes theorem is given as del cross E into ds. So by comparing these two equations, this left hand side is equal, so we can equate the terms in the right hand side. Right? So double integral del cross E ds equal to minus double integral dou B by dou t into ds. So integral available on both the sides, so that can be written as del cross E equal to minus dou B by dou t. So we got the expression in terms of electric field magnetic flux density, del cross E equal to minus dou B by dou t. This is also referred as a Maxwell's equation. Now we analyze the Faraday's law. Finally we got the equation that is termed as Maxwell's equation. Now we'll see one problem. Now we'll see this problem. A square coil with loop area 0.01 meter square. The area of this square coil is 0.01 meter square and having 50 turns is rotated about its axis at right angle to the uniform magnetic field of 1 Tesla. Right, one square coil with area 0.01 meter square with 50 turns available. It is rotating about its axis at right angle to the uniform magnetic field of 1 Tesla. We need to calculate the instantaneous value of EMF induced in the coil. We need to find induced EMF for 3 different conditions. At right angle to the field, at 45 degree to the field, in the plane of the field, right? And speed of rotation is given as 1000 rpm. right? Now we'll see the data, what are the given data available. Area is 0.01 meter square. Number of turns is 50. The magnetic flux density is 1 Tesla. The speed of rotation is 1000 rpm. Now we know that E equal to minus n d pi by dt. This d pi is nothing but pi m cos omega t. Right? So we need to differentiate with respect to t. So minus n, this pi m is constant. The differentiation of cos omega t is minus sin omega t into omega, because here omega t is available, so into omega. So here 1 minus is there, so it become plus n pi m sin omega t into omega. That is E equal to n b a omega into sin omega t. So this pi m is written as B into A, magnetic flux density into area, because pi m value is not available, B and A value is available, area available and magnetic flux density available. So that n pi m is written as B into A. Actually B equal to pi m by A, so pi m equal to B into A into omega sin omega t. Right? So by using this formula we can find the induced EMF for 3 different conditions. So first, right angle to the field, that is omega t equal to 0 degree. Right? In that sin 0 is 0, so totally the value will be 0. 0 degree. Due to 0 degree, the induced EMF will be 0. Next one, at 45 degree of the field, that is omega t equal to 45 degree. So in this what we need is omega value is needed. So omega equal to 2 pi n divided by 60. So 2 into pi into n is number of speed of rotation, 1000 divided by 60, so 104.7 radian per second. So we can substitute all the value. N is available 50, B is the 1 Tesla, area is 0.01, omega value we calculated 104.7 into sin omega t, that is sin 45 degree. So by simplifying all, what we got, 37 voltage, E equal to 37 voltage. Now if in the rotation in the plane of the field, that is omega t equal to 90 degree. Right? The same thing we can substitute n b a omega into sin 90 degree. Right? The all values are substituted. For sin 90 is equal to 1. So E equal to, by simplifying this, what we got, 52.3 voltage. Right? Now we got the induced EMF for all 3 cases, right angle, 45 degree and 90 degree. So in this video we discuss about the Faraday's law in terms of electromagnetic theory. We got finally the Maxwell's equation and we solved one problem. Thank you.